I'm probably not going to show you the bug. It takes too long to reproduce because it is a very bad performance bug, so it's going to be slow. But I can show you in the context of this. The variables panel, at one point this was not a scroll panel, and when I added a scroll panel for this variables panel, it made the whole thing extremely slow. Like just the startup of the app was very, very slow. I wanted to do Mike Donnell-Levy's random sample based technique, but there wasn't a ready way to do it because that way requires this Control C to exit out of the app. But that doesn't work now because I have taken over the keyboard. So I could maybe do some tweaking to get that to work, but I decided to go a different route. So so what I did was after I recreated the history file, like this history file, remember I had this C code.py that will print a timeline of the entire program.
Yes. Yeah,
like I did it for the Fibonacci, right? So
yeah.
So basically I did that and I spit it out into a text file. Okay, so I did this C code script to generate the timeline, and the timeline looks like this. So this is the module loader, Python module loader. So I can search for render all, which is my render function, for example. And now I can see, okay, on step 63,930, we started the render all function, right? And it's going through these things. And then I compared, like, what is the timeline like with the scroll widget on versus without the scroll widget on, which is this one. So the first thing I found was that the history file without this, and this was just starting up the app and letting it render. That's all I did with both of these. So the one without scroll bar has like just under 500k lines of Python code executed. The one with a scroll bar has 2 million. Has 2 million. Which is about 4 times as much. So I said, okay, why is that? I tried looking through it, but this is a lot of lines to look through. I tried diffing them. I just used the diff command on the command line. And 2 things that help when you're looking through this amount of data, you shrink the font size by a lot. And then you can use this scroll bar here. And one thing I saw was these amazingly deep nesting. These these great coastlines, I call them. Like these are amazing coastlines, and I saw this in the diff.
Like if you look at the coastlines, they like the code are like same sets of code. Does that mean it's in like a recursion or something?
Yes, exactly. Yeah, that's a good. Your spider sense is tingling. That's good. Yeah. So yeah, you can kind of sense this is recursion because the line of code is kind of repeating over and over. Same lines of code repeating. Yes, that's definitely a sign that this is recursion. So this is the diff, and this is so this should represent something that exists in the scroll version that does not exist in the non-scroll version, right? So I go back to the scroll version, like an overview of where these things are going. And at some point, the coastlines get kind of out of hand, like here.
Yeah.
Like here, yeah, it's really out of hand. It's like, wow. I mean, that's a lot of levels of nesting over here. This almost looks like a graph, which is very cool, right? When you think like it's a visual representation of the code execution.
Yeah.
Which I think this could be a very important concept because I feel that a lot of the work to try to improve programming itself are done to make the code look better, because the code is what we see. What we don't see is this, right? So I'm wondering if people see pictures like this one, or maybe there are other visual representations too, but I think this is a good one to focus on by itself. If people see pictures like this as a regular day-to-day occurrence, how would they treat the code, and how would they think about how to improve their tools, etc.? I think that's a very interesting thought to dig into.
Even people less likely to write recursion, because once you write recursion, it's gonna somehow look like this.
Well, the thing is, should it make you avoid recursion though? When you hit against an obstacle, you always have the choice of understanding it better so that you can control it, or avoiding it.
That's true.
And what I would like to get people to do is actually to understanding it better and being able to control it.
That's true.
So
Yeah.
so I have written some recursive code that have gone wrong, very wrong, right?
Mm-hmm.
So I could choose to okay, maybe I should stop writing recursive code, or actually try to solve this problem in.
That's true.
I just copied the code here, and I searched my source code to see which line it was in my source code, and it was this line. And this.
Okay.
By the way, this is the Sstring which you helped me with. And the Sstring is actually a fundamental building block in this UI framework now. It's been extremely helpful, but it's also brought me this problem. So so there is that. But actually, we kind of argued about whether to do this in a recursive way, and I argued that we should do it a recursive way. So I modified it to do that. Now
it's len is calling len itself. Like
len is calling len, but it's calling it on the children though, right?
Yeah. Okay.
So a Sstring group can have children, which a child can in turn be another Sstring group, right?
Well, so how deep this will recurse will it depend on how many children, how many levels of children it has?
Yeah, exactly. Okay. So this actually shows to me that the nesting in the data structure is very deep.
All right.
And I actually just took this line number because this line number is actually a marker for one point in time in my program. You can pass in this step number into the debugger, and the debugger will jump there.
Right.
And then when I did that, I looked at the data structure, like in terms of that tree, and I saw that, oh yeah, it has children. And I opened up the children, and that child has more children. And then it keeps going down very far, just like this structure here.
Mm-hmm.
So then the question is like, well, why is it nested so deep? Does it have to be? And after I looked through that data more closely, I realized, no, it did not have to be nested so deep. And the way to fix it was to do just a little bit of optimization. I paired with you on this function, actually, this getItem function. Do you remember this?
Yeah, vaguely remember.
Vaguely, yeah. It is like I have this getItem is to support, like, I have a string like this.
Okay.
Maybe it has some color.
Oh, it's like a slice.
Yeah, it's for the slice. I want to get from there, right? I want to get like a slice, but the problem is this string. It could be a combination. It could be like. It could be that, and I might slice across the hello and the world, right? So this loop is handling that logic.
Okay.
But it used to have just grab the results in chunks, and at the end, it just returns a group that has the results. Okay. And what I realized that it wraps it in another group, even if the result only has one element in it. So that was completely unnecessary. And I could have, so at first I was like, if it just has one element in it, just return that element, and instead of wrapping it in another group. And once I did that, it made the performance much better.
So why this will cause the recursion?
It causes a recursion in that it increased the level of nesting. It's like in this hollow world, like we have a hollow and then world, but they are different. They are come from different strings, right?
Right.
But in many cases, I don't go across the two different strings. Like if if the slice is just ELL, I got it's gonna end up with just one result in here, and then what I end up doing is wrapping that in another group. Like, so well, let's call it like that. So I end up double wrapping it. I just have this procedure that does that a lot of times. So what ends up happening is that gets unnecessarily rewrapped many times.
Oh, okay. I see.
Even if I did just this, is 1, then just return results at 0. Just by doing that, I was able to make the rendering basically as fast as the Nosegrow version.
Okay, I see.
But then there's another optimization that I did later, which improved even the Nosegrow version. Because even the Nosegrow version had some pretty big coastlines, even though they were not quite as big. And that was if I add two strings together, if I find that they're the same, have the same styles, then I merge them into the same string group.
Okay, I see.
I do a little sort of under the cover smarts to merge them. So I reduce the nesting, and that made it much faster. I guess I'll show you if I do the same thing to the version with Nosegrow, you get these coastlines that are not quite as big as the first one, right? It's not quite as out of control. And after the fix was put in place, the two fixes.
Oh,
it's much more calm. Yeah, it's much more calm, and there's no crazy coastlines anymore after the fix.
That is true. It's like if you want to use like less logic or like special cases, then the performance is much worse. But if you just like optimize just by putting in like early return of the special case, then but the code doesn't look as neat as before because you have this special treatment of certain things.
Yeah, that is true. You don't want to do that up front. Premature optimization is the root of all evil. Like we inherited that saying. That's because if you, in order to optimize for certain things, you have to do these one-off cases like this one. I ended up writing a reduce statement that is still pretty generic and short. And this reduce statement handle that case. If the results has one thing in it, it'll just return the one thing. Instead of doing any of the reduce stuff. So the code is still okay, but yeah. One thing I get from this is that why do we try to make the code clean, make the code easy to read, etc. You're trying to put out a high level of work. You want to do good work, and this is what you see, right? This is all you see when you're programming. There's also the UI. If you're a UI programmer, you also see the UI, and you want to make that look good as well. So you want to make the things you see look good, But this is not what you see.
That's true.
So what I'm proposing is, if this is what you see, then you would want to make this look good as well.
That is true. Yeah.
Yeah. It's not enough to make this code look good.
Mm-hmm.
You should also make this look good, because if the recursion goes crazy, that's not good.
That's true.
I think this is a really interesting way of debugging. For like the future of debugging, this is kind of what I have in mind, where people would look at these coastlines, or even other different visual representation of code that I haven't thought of. But I think this is definitely an important one here.
But how can you have this much data, like showing this much data to people, so that people can get what they want out of this?
We are looking at a lot of data, and I'm doing it. I'm already doing it.
Okay.
I'm just having to scroll through it, right?
Yeah, that's true.
And if the scrolling through my swiping gesture is too slow, then I'm just dragging this scroll bar to make it go faster.
Okay.
But to answer your question more directly, yes, I am thinking about how to make it more convenient to see the big picture when there's so much of it. One thing too is, this reminds me of Fractals. No, the poster behind me. Yeah, Fractals. This very much reminds me of Fractals, and I think that is super cool.
And I was thinking about when I use RSJS because RSJS help us getting your code cleaner, because your code is like, oh, you can have a mental picture of what is going on so that you don't have to mutate stuff again and again. But I feel like I don't know what exactly happened when I write this RSJS stuff. Maybe there something is processing like 1,000 times, but I have no visibility to it. Maybe if we print something like this in like an RSJS code, then you see some crazy stuff, but you just have no visibility.
Yeah. That's the cause of abstraction, and it's not just RxJS that does this. Any framework that claims that you can get a lot done by writing just a few lines of code. But if you are able to see this picture of what it did as a result of typing those few lines of code, like, is that still a good picture? Well, we don't know, because we don't have this picture.
Yeah.
But what if we did? Would that change things, right?
Well, sometimes it doesn't matter, because if you don't have to process a lot of data, then what, right? You don't care.
Yeah. It makes, if your few lines of code is reading in like a novel or a huge data set from the customer data of T-Mobile or something, and then you will see a picture that might get crazy. But if it's just like a little student homework problem that's sorting some lists or something like that,